Now we continue from where we stopped. There's a term known as rectilinear acceleration. Now, rectilinear acceleration is simply the rate of increase of velocity along a straight line, as the term implies. Rectilinear. This linear means it's occurring along a straight line in a unit time. Now, when the velocity of an object changes, it could be said to accelerate or decelerate. Acceleration is the increasing rate of velocity with time. So, acceleration is connoted positive. Now, there's its counterpart. Deceleration, similar to acceleration, on the other hand, is the decreasing rate of change of velocity with time. So, in deceleration, it is negative. So, deceleration is referred to as retardation or negative acceleration, but they are similar. Just take note of the sign conventions. Now let's look at the graphs. Now for acceleration, remember both acceleration and deceleration, they are changing velocity with respect to time. So we have velocity here in meter per second, and we have time here in seconds. Now acceleration from, let's see, our starting point O will simply be this. Now here's a keynote from the previous lesson. Yes, you can see that this graph looks similar to this graph, but here's a key point. On the y-axis we have displacement here for speed, while for the acceleration graph we have velocity here. So take note of what you're putting on your x and y axis. Now this is the graph for acceleration, whereas for deceleration you also have velocity in meter per second here, and we have time in seconds here. Now the graph of deceleration will look something like this. Let's assume this point to O and this point to R. So this signifies a decrease, the decreasing value, and this increasing. So this is for acceleration and this is for deceleration. Now in plotting your graphs, here are keynotes you need to take note of. The labeling of the x and y axis, the units of what you're putting on each axis, and when necessary, the title of the graph. What graph are you drawing? You need to make that clear, specify. Now in further videos, we're going to cover extensively various solutions, various problems concerning these concepts. But as for now, let's look at two examples. Now this is our given question. The student walks a distance of 3 kilometers in 20 minutes. Calculate his average speed. Now, average speed, as we discussed earlier, is given as distance divided by time. Now, our distance here is given as 3 kilometers. Now, our time is given in minutes, 20 minutes. Now, in this calculation, you want to take note of their units. When dealing with average speed or velocity, it's in meter per second, which is SI units, or it could be in kilometer per hour, like that. But you want to take very careful look at the units. Now we see here, this is in kilometer, this is in minutes, so I want mine to be in meter per second. So converting this to meter, 1 kilometer is equivalent to 1000 meter. Now this prefix here, kilo, means 10 raised to the power of 3. That's why it's simply 1 times 10 raised to the power of 3, then the meter. So 1 kilometer is 1000 meter. Therefore 3 kilometer is going to be 3000 meters. Now in the time, I want to convert it to second. 60 seconds make 1 minute. I have 20 minutes. I want to convert it to seconds, so I'm going to multiply by 60. So converting this to minutes to seconds, is going to be 20 times 60 seconds. This is going to give me 1200 seconds. Now, plugging back these values into my formula, I have 3000 meter divided by 1200 seconds. This is going to give me 2.5 meter per second. Now, example 2. Now, for example 2, we have a driver is traveling at a speed of 115 kilometers per hour, and he received a text message on his mobile phone. How far is he in kilometers 20 seconds later from when he received the text? Now feel free to pause and attempt the problem. Now this will be the solution. We're given the speed to be 115 kilometers per hour, and we're also given the time duration as 20 seconds. Now we're asked to find the distance. Now from original, previously, speed is distance over time. Therefore, making distance subject, distance will be speed times time. But in question, we are asked how far is he in kilometers. Therefore, we want our distance to be in kilometers as asked by the question. Therefore, we need our time to be in hour. Currently our time is in second and our speed is in kilometer per hour, which is perfect, but we need our time to be in hour so it can match the unit of the speed and cancel out the hour here. Now let's do a quick conversion. In 60 seconds we have 1 minute. In 60 minutes we have 1 hour. This implies that in 60 times 60 seconds, it will be equivalent to 1 hour, because 60 seconds is in a minute and we have 60 minutes in 1 hour. Now remember, we're trying to convert the time to hour. So if in 1 minute we have 60 seconds, how many seconds will we have in 60 minutes? So it will simply be 60 times 60 seconds. So in an hour we have 3,600 seconds. Now we're trying to convert seconds to hour, 20 seconds to hour. Therefore in 20 seconds, how many hours will we have? We're going to have 20 divided by 3,600 seconds. So this is going to be, this is an hour. So 20 divided by 3,600 hour. Now substituting this into our formula, we have distance to be speed. What is our value of our speed? 115 kilometer per hour multiplied by 20 over 3,600 hour. Now this hour cancels out nicely, just as we want, and we have our distance, the unit of our distance in kilometer, just as we asked in question. Now simplifying this is going to be 115 times 20 over 3,600 kilometers. This is going to equivalent to be 0.639 kilometer, and there we have it.